1.2 on the topic of sampling. So here are your learning objectives for this particular lecture. At the end of this lecture, the student should be able to define sampling frame and sampling error. The student should be also able to give one example of how to do simple random sampling and one example of how to do systematic sampling. The student should be able to explain one reason to choose stratified sampling over other approaches, state two differences between cluster sampling and convenience sampling, and give an example of a national survey that uses multi-stage sampling. So let's jump right into it here. So we're going to go over in this lecture sampling definitions, and then those different types of sampling I mentioned in the learning objectives: simple random sampling, stratified sampling, systematic sampling, and then convenience and multi-stage sampling. So let's start with some sampling definitions. What is a sample? Okay, so we're going to revisit that concept from the previous lecture. We're also going to talk about sampling frames and what errors mean and errors of sampling frames. And then we're also going to just go right back over that and make sure you understand before we go on and talk about the different types of sampling. So we take a sample of a population because we want to do inferential statistics. Remember that? We want to infer from the sample to the population. And it's just not necessary to measure the whole population. It would be impractical and it costs a lot. And actually, what you'll find is if you ever do an experiment where you actually do measure the whole population, you'll find that if you get, a pretty good proportion of the population, you just take that, that's all you really needed to talk to. So ultimately, we save resources, especially in healthcare, when we do a good job of sampling and use that to infer to the population rather than having to take a census of the whole population all the time. So that brings us to the concept of sampling frame.
I need to go back, go to that whole thing.
And even talked about a few examples there. So I hope you enjoyed my lecture. Greetings, this is Monica Wahi, section 1. So here are your learning objectives for this particular lecture. At the end of this lecture, the student should be able to define sampling frame and sampling error. The student should be also able to give one example of how to do simple random sampling and one example of how to do systematic sampling. The student should be able to explain one reason to choose stratified sampling over other approaches, state two differences between cluster sampling and convenience sampling, and give an example of a national survey that uses multi-stage sampling. So let's jump right into it here. So we're going to go over in this lecture sampling definitions, and then those different types of sampling I mentioned in the learning objectives: simple random sampling, stratified sampling, systematic sampling, and then convenience and multi-stage sampling. So let's start with some sampling definitions. What is a sample? Okay, so we're going to revisit that concept from the previous lecture. We're also going to talk about sampling frames and what errors mean and errors of sampling frames. And then we're also going to just go right back over that and make sure you understand before we go on and talk about the different types of sampling. So we take a sample of a population because we want to do inferential statistics. Remember that? We want to infer from the sample to the population. And it's just not necessary to measure the whole population. It would be impractical and it costs a lot. And actually, what you'll find is if you ever do an experiment where you actually do measure the whole population, you'll find that if you get, a pretty good proportion of the population, you just take that, that's all you really needed to talk to. So ultimately, we save resources, especially in healthcare, when we do a good job of sampling and use that to infer to the population rather than having to take a census of the whole population all the time. So that brings us to the concept sampling frame. So the same rather than having to take a census of the whole population all the time. So that brings us to the concept of sampling frame. So the sampling frame is the list of individuals from which a sample is actually selected. And the list may be this physical concrete list, like you can have a list of students enrolled at a nursing college. Or in my other lecture, I gave an example of a list of nurses who work at Massachusetts General Hospital. That could be your list. You go to Human Resources and get that. Or it could be a theoretical list. It could be like the list of patients who present to the emergency department today. Obviously, when you go into work at the beginning of your shift, you're not going to know who's on that list yet. But it could be a theoretical list. But whatever that list is, that is your sampling frame. So that those are the people who actually could be selected for your study. That list is who's on that list yet, but it could be a theoretical list. But whatever that list is, that is your sampling frame. So that those are the people who actually could be selected for your study. So the sampling frame is the part of the population for which you want to draw the sample. And you want to work it such that everybody from your sampling frame has a chance of being selected for your sample. In other words, you don't want to leave anyone that should be in your sampling frame out in the cold. That leads us to the concept of undercoverage. So what is it? It's omitting population members from the sampling frame. They're supposed to be on the list, but they're not there. So how can this happen? Well, let's say you did what I was suggesting in the previous slide. You got a list of nursing students, from a college. Let's say somebody signed up that day, or somebody was just admitted that day. Maybe they didn't make it into the database. You're missing them. Or even like that HR list I talked about at MGH. Well, I know how nurses are sometimes on temp in different places, and maybe they're not on the payroll. Maybe they're through a temp agency. And so then we would miss those nurses from the sampling. And then, people who present at the emergency department at night might be different than those in the day. And so if you're really trying to sample from people who present to the emergency department, you can't just look at like some small period of time. You'd have to look at, the whole 24-hour cycle. So if you omit population members from your sampling frame, they don't even get a chance to be in it. And that's called undercoverage. Now I'm going to shift around. We're jumping around with different definitions. And we're going to talk about errors. Now this is something that took me a while to get used to in statistics. There's actually two kinds of errors in statistics. The first kind is, I call it, this is my own terminology, a fact of life error. It's just an error that happens when you do statistics. It's not bad or good, it's just what happens. And in this case, I'm going to describe one of those. It's called a sampling error. So the sampling error just simply says the population mean will be different from your sample mean. And the population percentage will be different from your sample percentage. So what does that mean? That means that if I cut corners, like I said I could, right, and just take a sample to infer to the population, if I actually do a sample. So the sampling error just simply says the population mean will be different from your sample mean. And the population percentage will be different from your sample percentage. So what does that mean? That means that if I cut corners, like I said I could, right, and just take a sample to infer to the population, if I actually do one of those experiments I was telling you about where I have the population data the same, but they're typically different. Same if you do percentages. And we just know this is going to happen in statistics. We account for it. We have ways of dealing with it. But we know that there's one of those.
What is it? What is causing it to
avoid? Well, we just talked about sampling error. That's just a fact of life error. But errors you want to avoid, non-sampling error. That's basically using a bad list. I had an example in my life where I wanted to study a whole bunch of providers, right? And my friend gave me this list of providers and said, this is the entire list of all these providers in this particular professional society. But when I sent the email to that list, I found there were not only duplicates on this list, but a lot of people emailed me back and said, "Why are you sending this to me? I'm not a provider. I'm not part of this professional society." And also, some people who were in that professional society who had heard about the survey emailed me and said, "Why didn't I get the survey?" So this was a bad list. Some people had been left out of the sampling frame. So people who were in the society somehow weren't on my email list, and that's a problem, right? So you have to pay careful attention. This was actually a mistake I made. You have to pay careful attention that everyone in the population who's supposed to be represented in your sampling frame is actually there. So I should have really done a better job calling the professional society and making sure that this list was a good list. So sampling error was caused by the fact that regardless of what you do, your sample will not perfectly represent the population. Whereas non-sampling error, yeah, I was sloppy. It was poor sample design, sloppy data collection, inaccurate measurement instruments. You can have bias in data collection, other problems introduced by the researcher. So this is your fault if there's non-sampling error. But sampling error, that's just the fact of life. Little whiplash here, we're going to now move on to the concept of simulations. So a simulation is defined technically as a numerical facsimile or representation of a real world phenomenon. So it's like working through a pretend situation to see how it will come out in the case it was real. And this, when you study statistics, you end up doing a lot of simulations. And remember how I've been talking about an experiment you could do if you somehow did a census and had a whole bunch of data on a population? You could do an experiment where you just took a sample from that population and looked at their mean to see the sampling error. That's an example of a simulation. So to just conclude this little section, it's really important to do your best to avoid non-sampling error. And this is achieved by making sure you do not have undercoverage when sampling from your sampling frame. So this puts together some of our vocabulary. But just remember, sampling error is effective. Okay, now we're going to specifically talk about different types of sampling. And we're going to start with simple random sampling. Okay, so first we're going to start with just explaining what is meant by simple random sampling. Then we're going to talk about two different methods of doing simple random sampling. They work the same way. They achieve the same thing. It's just that depending on how you're doing your research, one might be more convenient for you than the other. Finally, we will go over the limits of simple random sampling. Because all these sampling methods seem perfect, but then you got to take a look at their limitations. So let's first define simple random sampling. So here's a definition. A simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. Well, that's kind of complicated, but what it means is that if you use the proper approach for simple random sampling, whatever sample you get, you could have had just as easy a chance of getting another batch, another group of people from that sample. In other words, like let's say you have a list of the population of students in a class. So I'm going to define a class as a population. And you want to take a sample of 5 students from this bigger class. If you take a simple random sample, it means that all the different groups of 5 students you could pick from the list has an equal chance of being the sample group you actually pick. Now, you can just imagine that if you race into the class right at the beginning and you take your sample of 5 and not everybody's in the class, what does that sound like, right? A sampling frame problem, maybe an undercoverage problem, maybe biases creeping in there, right? And so you just got to be careful if you're going to do simple random sampling that you start with a list with everybody in your sample frame, because Every single sample that you could possibly take should have equal chance of ending up being your sample. And I'll
Basically,
kind of
just removing any
explain
possible
it
error,
by explaining the two different
as far as I can
methods
tell.
that can be used of obtaining that sample. So one of the best things that you can do is just start with a really good list of all the people in your population. So maybe, if I was going to study, I used to work at the Army. So let's say I was going to study all the people who are active duty in the U.S. Army. I would like to get a list of all of those people from an accurate place at the Army. And I would like to have them have a unique ID. Okay? And that's true in the Army. Everybody in the Army has a unique numerical ID. So what I would do, like in here, if you were looking at students, you'd maybe take a student ID. So then you take the IDs from everybody on the list and you cut them up, like you print them out, you cut them up, and you put them in a hat, right? Or a bag where you can't see it. Then you mix them all up where you can't see it, and you draw 5 of them out. Or like in the picture, what they did was mix up all those papers, and now they're not looking, and they're drawing a few out, okay? So what did you just do? You just made sure, first of all, that everybody in the population had an ID number, and that when you printed it out and cut it up, you didn't lose any of them. If you drop them on the floor or something, that's not simple random sampling. You got to make sure you keep all of them, and that you put them all in the hat, and that you didn't look, and you drew out 5 or whatever, because then any 5 of those slips of paper could have been drawn, and therefore you're meeting with simple random sampling. Okay, that method will work, right? Another method that works, that might work better if you can't do this ID thing where you cut up paper, is where you simply just make your own list of unique random numbers, right? You just make your own list. And then you assign those to the population. A great example is if you're, kind of teaching kids and you want to put them in a random order, maybe you're going to do a game or something. Well, all you do is you get, like, let's say you have 10 kids, you number 1 to 10, you put it in a hat, and then you pull out the first number, let's say it's 5, you give it to the first kid, right? And then you just keep pulling out numbers and giving them to the kids and then tell them to stand in order, right? So you generate a list of random numbers as long as the list of the population. So I said, what if you have 10 kids? Well, if you have, 500 names, then you get 500 numbers. And they don't have to be 1 through 500. They just have to be unique. Okay, I like smaller numbers, so I'd say keep them small. But you could do what you want. And then, in any case, you randomly assign these numbers. You can use the hat. I'm big on hats. To this population. And then, you ask them to stand in order, or somehow you figure out, it's kind of like a raffle. You call out, who's got number 1, and whoever says yes, you're like, you're lucky, you get to be in my study, So you can take the first 5 numbers in the order, right? And that'll achieve the same thing as the last method. You'll get a simple random sample. It's just 2 different ways of doing it. So ultimately, being in a simple random sample means that the sample has an equal chance of being selected out of the hat, that this group of people or group of whatever has an equal chance of being selected. And you'll see this picture on the left here is bingo. Some of you may play bingo. They pull balls out of there and they call off the names of the balls. Well, each ball has a unique, actually a letter and a number, a unique ID on there. And that's how they make them random. They take a simple random sample of these bingo balls each time that they do a bingo game. So I described to you the first method of doing that using an old-fashioned hat. The second method, where you generate your own numbers and you just make sure they're unique and then you assign them to things and put them in order. Well, that's my electronic hat. That's how I handle it if I have, for example, somebody sends me an Excel sheet with a list of hospitals on it. I'll just assign each hospital a random number and sort them in order, and I'll sample the top few hospitals. That'll be how I get a simple random sample. That way I'm not biased, picking out my favorite hospitals where all my friends work, right? If I do it that way, the first method or the second method, all members of the population have an equal probability of being selected in the sample, and more importantly, all possible samples, all possible groups, had an equal chance of being selected. Of course, I only did it once, so I only got one of them. But the other ones that weren't selected had an equal chance of being selected. All right, you probably saw the list. It's a whole list. Even if I'm sampling hospitals of being selected.
Oh, okay. There's only two. I
All
thought there were
right, you
three.
probably saw the limits. It's
That's
this whole list. Even if I'm sampling hospitals, right, I still need a list of hospitals to sample from. So you may not know who's going to show up in the emergency department that day. If you do, well, you're psychic, because most people are not. So how would you sample from them using simple random sampling? So simple random sampling is okay when you got a list like hospitals, but it's not so good when you don't know who's going to show up that day.
That's not don't. That's
And
dotted.
even if you do a simple random sampling, you need a good list. I made a mistake once where I did a survey with a bunch of professionals using a professional society list. And when I sent out the survey, I learned that there were people on the list who were no longer part of the society, that it was an old list. And more importantly, there were people who had joined the society that had not made it onto that list, so I was getting under coverage. So like if you were doing a study with students, you know, what if they just left off the part-time students, and you'd be missing them. So this is a great example of non-sampling error. And so if you're going to do simple random sampling, you do need a list, and you really want to research it and make sure it's the best list possible. So I just went over the characteristics of simple random sampling and two different methods you can use to sample from a list. And I also mentioned the limits of it. Now we'll talk about a different kind of sampling, stratified sampling. So we're going to go over what it is, and then just like simple random sampling had all these steps to it, there are different steps in stratified sampling. And I'll give you some examples, and then of course, just like simple random sampling, this stratified sampling has limitations, and I'll talk about those. So I first wanted to just remind you what the word stratified means, or what strata are. The single word is stratum, and more than one is strata. Now you see that rock on the slide. You see that big horizontal line across it? That's a stratum. They're a strata, right? Those are strata of rock. If you study geology, the geologist will explain that where those breaks are, it means something happened, often in the weather or the environment or whatever. But the reason why I put this picture up there is I want you to sort of imagine those layers. Because that's what we do in stratified sampling. Is first, we divide our list. Of course, you need a list. We divide our list into layers. Okay? So remember how I was just talking about simple random sampling? Like, what if I sampled from hospitals? Well, I could take this hospital list and divide it into layers by, for example, how close they are to the city. I could say urban, suburban, and rural. I could first put them into those strata, okay? And if I was doing that, I'd be doing stratified sampling. Same with students. Like, I could put them in, you know, first year nursing students, second year students, you know, and I'd have them divided into strata first. So this is why. So why would you do that? Why not just do simple random sampling? Well, if you think about it, let's say that you've got a class like statistics, maybe a lot of, you know, there are not that many first year students in it. So let's say the very small proportion is that way. If you do simple random sampling, you might just buy a lot.
So tired.
Right? And so if you're really concerned about what a minority thinks, then you can make sure to get representative from that stratum by doing stratified sampling. Because the first thing you do is you put that list into groups, and then you put a simple random sample from each. So here's the steps. So step one, divide the entire population, the whole list you have, into distinct subgroups called strata. And remember, each individual has to fit into one of those categories. So if you have somebody who's sort of halfway between first year and second year, or you've got a hospital that's kind of on the border, you got to choose. You got to put it in one of those groups. Step two, well, it's not really step two, but you've got to think about the strata. Like, what is it based on? It's got to be based on one specific characteristic, such as age, income, education level. A great example is you could take people of all different incomes, right? That's a quantitative variable.
Incomes.
But you could put them in strata by, less than a certain amount, and then that to that, that to that. You can make, 4 or 5 strata. And then, you just want to make sure that all members of the stratum, each stratum, share the same characteristic. And then you could do step 4, which is draw a simple random sample from each stratum.
Okay, I'm
So,
totally
like in
missed
the
this
case
step.
where I was describing, like maybe you have a class with very few first year students, if you take a random sample of 5 from each strata, each stratum, then you might be, you're kind of getting almost like extra votes from a small minority, right? Like you're kind of treating them fairly, even though there's a way bigger group of the other people you're taking exactly 5 from. And a small minority, right?
Hold on. So first step was divided into subgroups called strata. Put just EX there. EX income amounts. And then base on characteristics. Such as age. Dang it. That doesn't go up there. It does go on second one. Based on characteristics, age, income, education. etc. And then make sure all have the same character or share the characteristic. Characteristic. Four is drawn SRS. I don't think they said that was, unless it was stratified sampling. I'm not sure. I'll have to check that.
Like you're kind of treating them fairly, even though there's a way bigger group of the other people you're taking exactly 5 from. And but you just that's the risk you take, because you want to make sure you hear from that small group. Because if you just do random sampling, the group's so small, you might just accidentally miss it. So here are some examples of stratified sampling. And you'll see this
students from each
in
grade.
the behavioral risk factor surveillance surveys. that they do in high schools, that they'll stratify by grade, right? Because if they did a simple random sample, a lot of students drop out of junior and senior year. They get probably too many freshmen and sophomores. And so they're going to want to look at getting a certain amount of freshman classes, a certain amount of sophomore classes, a certain amount of junior classes, a certain amount of senior classes, so they can have enough of each to make good estimates, right? And in hospitals,
sampling
they
from
often
patients or providers
sample
in
providers
departments.
from each department,
Okay.
right? Like they don't just do a simple random sample of providers if they're asking about like provider satisfaction or if you know about a policy. They won't just do that because they might, for example, miss everybody in the ICU. Or if you're studying,
Sorry.
you know,
Hospitals,
ICUs, you have
providers,
multiple ICUs
patients,
there,
each department.
then you would want to maybe stratify by ICU just to make sure, even if one of them's smaller, just making sure you have a good solid representation from each ICU. So those are the reasons that push you to do stratified sampling. It's not always necessary, but when you have these situations where you have these distinct groups, especially a little one involved, and you want to hear from everybody, you really want to consider the stratified sampling. So, of course, there's limitations, and I've been sort of leading up to this. What you end up doing is oversampling one of the groups, usually. Like the smallest group, if you make the same amount of people you take from that stratum, the same amount as you take from the big stratum, it's like the smallest group is having all these powerful votes, and the biggest group is weaker. They're made equal when they're not technically equal in the population. But that's the way it goes, right? And I do higher level statistics. There's ways to adjust back for that, to just sort of say, take a penalty for that. Go back and say, well, what if the real we can extrapolate this back to the population proportions. It's possible, but it takes some post processing. It's just the issue. And it's also like simple random sampling, not really possible to do with
Can't do lists beforehand.
And it's also hard to do because you actually have to split the list into groups, into these strata. So let's say I had these hospitals and I didn't know where they were. I didn't know exactly if they were urban or rural or suburban. Well, that adds another level of complexity to stratified sampling. So, in summary, I just went over what stratified means, and it means putting things in groups and then taking them. And I described the steps involved, and it's stratified sampling goes a lot more easily if the strata just happen to be equal to begin with. I gave the example of high schools. Usually there's maybe slightly fewer people in junior and senior year, but it's kind of close. And it's always nice, like if you're comparing ICUs, for example, if the ICUs are roughly the same size, because then you don't have to worry about one of them is smaller, but it's getting an equal. Alrighty, now we are going to move on to talk about systematic sampling. Okay, well, systematic sampling actually can be done with or without a list. It's a little more flexible than the kind of sampling we've been talking about. Systematic sampling, it's easier for me to define it by describing the steps you go through to do it. So I'm just going to explain how to do it, and then you'll understand it. In fact, you'll understand why it's called systematic. So whether you have a list or not, what you have to do for step one is arrange all the individuals of the population in a particular order. Now, if it's a list, you just make it in whatever order you want to make it in. But if we're talking about, for example, patients coming into the ER, well, they come in the order that they want to. So they already are arranged in the list, right? You just don't have to list it. Okay, then step two is pick a random individual as a start. So let's say I had a list of hospitals, and let's say it was just sorted by state, right? Let's say I picked a random individual. Maybe I went down, 7 on the list, and I picked that hospital. Or maybe you could be at the ER, you start your shift, and the 7th patient who is admitted to the ER, you pick that person. I picked 7. I mean, you could have picked 5, you could have picked 20. Just you pick a random person. Then the next step, step 3, is take every kth member of the population in the sample. Now, don't try this in Scrabble. Kth is not a word in Scrabble, okay? It's just a word in statistics ease. And what kth means, spelled KTH, it means every so many. So let's pick a number and fill it in for K. So let's pick the number 3. So let's say after you picked your first hospital from the list or the first patient from the ER, it doesn't matter what number you chose for that, then you take every third after that. So every third patient that comes in after that, you ask them if they want to be in the study, or every third hospital after that original random one, I pick and I say, okay, this is going to be part of my systematic sample. So as you can see, it's like pretty simple to do. It's easy to do if you have a list. It's easy to do if you don't have a list. It's just the deal is you have to pick K. Well, first you pick a random place to start, then you pick K, and then you just keep going every so minute. So you could do this with classes. You could take
About
a
20 minutes left on this
at your
section.
college next semester. Just pick a random number like 3.
I don't know. Should I
Just
keep going with it?
way. So you go to the third class and you circle that. Then you pick another random number like 5, and then after that you pick every 5th class. So after the third one you go 4, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, and you keep picking classes. Okay, this is not career advice, okay? Do not pick your classes that way. This was just an example. All right, so as you probably guessed, I'm going to be negative Nelly again. There are problems with systematic sampling. If already things are set up boy, girl, for example, if you pick like an even number, you're going to get all boys or all girls, right? And I noticed this actually when I was doing a study in the lab. We wanted to study like whenever they put the assay through the machines. We thought some of the assays weren't running right, so we wanted to take a sample. And I wanted to take a systematic sample, but I wanted to take a systematic sample like every 7 days, and that's a week. And so I asked my colleague, does the lab vary day by day in what assays it runs? Because if it always runs the sexually transmitted disease assays, it saves them up and runs them all on Friday, and I'm sampling from every Friday, that's all I'm going to get, right? That's actually called periodicity. You don't have to remember that. I don't think I've ever even seen it written. It's just I remember my lecturer in my class telling us that that's what you have to worry about with systematic sampling. It's not a real common problem, though. But what's awesome about it is you can do it in a clinical setting. So you can sample patients that way coming into a clinic or coming to a central lab or like an emergency room. And that's why this is a particularly powerful way to sample, is that if you have an ongoing sort of patient influx, when you design your research, you could simply say, once you decide how many people you need to recruit for your sample, that you would use systematic sampling and just have somebody in the clinic inviting every kth person who qualifies, every kth patient who qualifies into your study. So it's easy to do. Systematic sampling is easy to do with or without a list. And you just pick a random starting point, and then you pick every kth individual. Next, we're going to move on to cluster sampling. So what is up with cluster sampling? Why do we need even other kinds of sampling? I just went over so many kinds. I mean, you could use stratified, systematic, or simple random sampling. Why would you even need another kind? Well, cluster is very special. It's special because it's the kind of sampling you use when you think there's a problem at a particular geographic location. Typically, that's how cluster sampling is used. And I'll explain it further. Imagine, for example, there's a particular factory that is believed to emit fumes that cause problems with people's health. Well, you can't do simple random sampling all over the nation, right? Or you won't even get people by that factory. You can't really easily do stratified or systematic sampling there. Cluster sampling is what's designed when you want to study something that's coming from a geographic location. So when you do cluster sampling, you start by dividing a map into geographic areas. So I'm from Minnesota, and I know that there was a mine there with vermiculite in it, um, and it was contaminated. A lot of people got sick from it, but they didn't know that's what was going on. So they first, I think, divided Minnesota into different geographic areas. After dividing the area into these different geographic areas, some with the bad thing in it, and some without the bad thing in it, you randomly pick these clusters or areas from the map. So, like if you'll see there on the screen, there's a map of the state of Virginia, and it's all been divided into different groups, and then this cluster is highlighted. You'd usually probably pick more than one cluster. Sometimes it's only four or five. But the idea is you try to enroll all of the individuals in the cluster. It's usually people. Although you can do it with animals, if there's a disease going around among animals, you would have you divide the area up into clusters, and then you try to measure all the animals in the cluster. So, as you can imagine, not only is this sort of practically difficult, but there's reasons why people live together, right? People live in communities. I mean, people don't just randomly scatter themselves. Cultural communities grow. Communities grow around art. Affluent communities have different people in them than communities that have less money. So sometimes the people located in a cluster are all somewhere in a way that makes the problem hard to study. And this is especially if you're studying some geographic thing, like maybe a factory or a sewage plant, that you think might be causing cancer. If you're in an area where there's a lot of pollution anyway from other things, and a lot of low income people live there because if you're high income, you can afford not to, well, they're already being exposed to higher rates of carcinogens and probably have a higher cancer rate. It's hard to tell what the independent effect might be of that thing in that geographic location because of the other similarities of the people around. And so cancer ends up being a really difficult, tough nut to crack because where we see high rates, there are often a lot of different geographic issues going on there, and cluster sampling doesn't really help tease that out. So to wrap this up, cluster sampling is used when geography is important. So if there is something geographically located in a certain spot and you can't move it, then you kind of are stuck doing cluster sampling. So briefly, the map around that area is divided into different sub areas, right? And those, not all the areas are picked, just a few are randomly picked. And then all of the people in that particular area are sampled. And of course, it's biased towards the people living in the area. If in the area you pick with a bunch of affluent people, you'll get affluent people. Pick an area with a bunch of immigrants, you'll get immigrants. And so, cluster sampling is not perfect, but you're kind of stuck with it when there's a situation
people in the area.
How I always remember it is, when I used to live in Florida, we'd like to drive up to Georgia because they had the best pecan clusters. That's like a type of dessert with pecans and caramel and stuff. So when I think of cluster sampling, I think of those pecan clusters, and they're only really good in Georgia. So that's my way of remembering that cluster sampling has to do with geography. Now, I'm finally going to talk about the last two types of sampling that I'm going to cover in this lecture. Convenience sampling and multi-stage sampling. They're both a little quick, so I'm going to just cover them quick. First, we're going to start by talking about convenience sampling, and we like that name, right? It's convenient. Convenient sampling can be used under low-risk circumstances, like if the findings of what you're doing aren't really that important. Like, for instance, let's say that you wanted to know what ice cream is the best from the restaurant next to the hospital. Let's say a new restaurant opens up. And you're going to go off your diet, you're going to go get some ice cream.
Results often
but you don't want to waste it, right? So you want to ask people what's the best one. You might ask your coworkers. You might ask, the people at the restaurant, hey, what's the best ice cream? But the results are not so reliable because you might end up on Yelp and see that other people disagree. So, convenient sampling is basically discrete.
Low risk circumstances. often not reliable. Low risk circumstances. Okay. There we go.
So, convenient sampling is basically using results or data that are conveniently or readily obtained. In my master's degree, one of the things I did was I surveyed people anonymously who were coming to a health fair. I sat at a booth and I gave them the survey, a few questions in it. That was definitely a convenience sample.
Conveniently,
Just people
or
showing up for the health.
readily.
And this can be useful when there's not a lot of resources allocated to the study, like I was a starving master's student, right? Like I didn't have any money. So that was perfect for me, convenience sampling. And also, the questions I was asking them about were just
So this is the kind of stuff
whether or
that
not
like
they
you'll
had
do in
risk for
school,
diabetes.
where they
Well,
just
I'm
send
not a
one out to
doctor,
every
so I
class
didn't
and
do
every
it for it.
person.
But it was interesting. So
I
it
hate
was a
those
very
surveys so
high-risk
much.
survey to fill out. And convenient sampling is convenient because it uses an already assembled group for surveys, like I was doing at the health fair.
Already assembled.
An example might be to ask patients in the waiting room to fill out a survey, or ask students in the class. Sometimes I do when I'm teaching. I'll do a convenient sample. Whoever's sitting there, I'll say, "Hey, is the homework that I assigned you this week too hard?" Well, it's always too hard. I don't even know why I do the survey. But anyway, sometimes as a teacher, you'll just want to do a convenient sample just to get the gauge on where the class is. But there are problems with it, right? You can't just use it for everything, even though it's nice and convenient. There's bias in every group, right? So if I let everybody go on break and then whoever's still sitting there asks them if the homework's too hard, I might get a totally different answer than if I waited for everybody to come back, right? And just about any time you just waltz into a room, like when I went to the health fair, who do you think is there? A bunch of sick people? No, there's a bunch of health-minded people there, and so I'm going to get a bunch of bias, right? And also, more importantly, when you do convenience sampling, you often miss important subpopulations. So remember stratified sampling, how sometimes people don't group evenly into the different strata? Maybe they do kind of in high schools, but especially when it comes to job
That's so small. There's no way anybody can read that.
Fewer bigwigs than they do lackeys.
Results
right?
can be biased.
And if they just have a few bigwigs, if you do a simple random sample, you might miss all of them. So maybe you try a stratified sample. On the other hand, if you walk into the break room that is used by the lackeys, and you say, "Hey, want to fill out my, work satisfaction survey?" All of the ones you're going to get are going to be from the lackeys. You're not going to get any representation from the upper job classes because they don't go in that lounge. So you'd be missing them. So that's the main problem with convenience sample, is the results can be so severely biased because you're only asking the small biased group of people that probably are all alike in some way. Not very representative.
Accidentally knocked the camera down. Whoops.
Next, I'm going to talk about multi-stage sampling. So, if you have a kid, the kid's crying, somebody's like, "What's up?" You say, "Well, the kid's going through stage." Well, that's exactly what you're doing when you're doing multi-stage sampling, is you're going through stages. It's basically like mixing and matching the different sampling I just talked about. Only you do one stage and then 2 stages and then 3 stages and then 4 stages, or maybe even more, and that's how you get your sample. So if you're imagining, wow, I got to start with a lot of people, you're probably right.
So probably for small groups, and
I made up of a way that
making sure that you don't have bias in it for
you could start with stage 1 as a cluster sample, right? Remember where you take out a map and then you divide it into areas? Well, let's divide it into states and take 2 census regions of states, like about 10 states from those clumps. Okay, now we've limited to that. Now let's go to stage 2 of our multi-stage sampling. Now, from each of those, we could take a random sample of counties,
Okay, so
right? So
one
we go
cluster
look at all the
sample.
counties and take a random sample.
Two is random sample of the
Then
counties.
after we get those counties,
Okay, so it gets
stage
smaller
3,
and smaller.
we can take a stratified sample of schools
So
from
we'll
each
go
county.
MS.
So
Smaller
some of the
and
counties
smaller.
will be totally rural, some will be totally urban, but most will have some mix. So we'll take a few schools from the urban, a few schools from the rural. In stage 3, from the stratified, we'll take a stratified sample of schools from the simple random sample of counties from the cluster sample of states. Okay, now we got our schools. Stage
That way I
4
don't
could
have
be
to cram
a
all of the
stratified
steps
sample
into
of classrooms.
what space
So
I have
once
left.
we figure
Gosh,
out
dang
our
it.
urban schools and our rural schools,
Oh, it's because I'm pulling on
we
the
can go
cord
in
with
there
my
and look at
foot.
all the classrooms,
I'm an idiot.
freshman, sophomore, junior, senior, and take a stratified sample of those. So it's basically mixing and matching, but you're right. You got to start with a lot to begin with if you're going to whittle it down in a whole bunch of stages. It doesn't have to be 4. I just gave you 4. Now I'm going to give you a real life example. This is the National Health and Nutrition Examination Survey, NHANES. Definitely not a master's project. This is done by the Centers for Disease Control and Prevention at the United States, right? So what I'm kind of hinting towards is the kinds of places doing multi-stage sampling are governments. Not only do you have to start with a whole bunch of people and things and individuals, states and schools and what have you, right? Is that it's a lot of work to do all the sampling, and it better be for a good reason. And the National Health and Nutrition Examination Survey is a good reason. That's a survey that's done by the CDC to try and measure America's health. Of course, it's doing inferential statistics, right? It's taking a sample and trying to
Because I already took
extrapolate
up
that
all the room.
information back to the population. And so it's got to be really careful about how it does its sampling. Can't just waltz
That's the
into
last part of it.
convenient sampling.
Looks like it's about the
So
last
this
part
is
of
how
it.
it does it. Just briefly, they start by, in stage 1, sampling counties. Then from those counties, they sample something called segments, which is defined in the census. They're different areas. From those segments, those areas, they sample households. And that's what they mean. Like, wherever you live is a household. Even if you live in a dorm, that's a household. Or you live in assisted living, that's a household. An apartment building, a house. So they sample those, and once they knock on your door of your household, they sample individuals from the household. So they use
I think they put surveys with the census, don't they? Whenever they do the U.S. census to get the population.
So in summary, convenience and multi-stage
I don't remember if they do that. I think they do.
With respect to convenience sampling, you want
Avoid
to avoid
using
it unless it's really a low risk.
So avoid convenience.
And you also want to avoid it unless it's really the only type of sampling possible under the circumstances. When you have situations where you have patients with very rare disease, probably convenience sampling from your rare disease clinic.
Using resources are low. Okay.
It's also used when resources are low. And so those are a few good reasons to try to use convenience sampling. It's really something that you want to use only if it's the thing you're stuck with. It's much better to look towards these other sampling approaches I described.
Multi-stage is
multi-stage
large, often governmental.
It's usually used in large governmental studies. So don't expect to actually design anything alone with multi-stage sampling. When that happens, I showed you those 4 things for that survey that the CDC does. Hundreds of people work on that. Even just the sampling, tons of people work to try and set that up. It's very difficult. But I wanted you to know about that kind of because it's important in healthcare. It happens a lot. So in conclusion, we made it through the sampling lecture, didn't we? I first started by describing some definitions you needed to be able to understand all these different types of sampling. Then I went into simple random sampling and showed you how to do it 2 different ways and what it achieves.
Go ahead and put double lines so I know that it's in that section.
We next talked about stratified sampling, why you do that and how you do that, and the limitations of that too. Then we got into systematic sampling.
Let's see. 3 pages? No, 2 pages. No, 3.
Next, we talked about cluster sampling.
Okay, about 5 pages.
Why you might need to pull that tool out of your sampling toolbox. And then finally, we covered convenience sampling.
Go ahead and show all 5 of those. Just so it's at the
Alrighty,
end of the
well,
stream.
I hope you better understand sampling now and can keep all of these different types of sampling.
Okay.
Hello, everybody.
11 pause there. So that was the end of that section. So let's see if I can put it in full view of the camera. Oh, that's trippy. I'm trying to figure out how to do that. Let's see. I think if I do it like that, it'll pretty much get it. There we go. So that's that page. Second one. Third one. It's this side. Hopefully that's not too loud. That's actually legible from the camera. Yes. And then I think that's almost the last one. No, that's the 4th one. Bring it down so it's actually visible mostly. There we go. So that should be visible, I think. And last one is just a little bit. So that's the last one, just so it's at the end of the stream if anybody wanted to like copy that down for whatever reason. Alright, so that was about all I intended to do for tonight. I'm already tired, so I'm probably going to end it here. If anybody joined in, thank you for watching.